Good morning, everybody. Welcome to beautiful yet rainy Huntington Beach. It's a pleasure to be with you this morning. My name is Guillaume Egles. I represent Aspera. And before we get into more details, just show of hands, who knows about Aspera or has used our products in the past? OK, great. So a good part of you. And basically, just as an introduction, Aspera, we've been for 10 plus years now using our core technology, FASP. We've really made a radical improvement in large file transfers for our customers. And those are especially in the M&E business. Our technology has won many awards. We have 2 Emmys. And it's very likely that over the past week, you've watched some video online that has been moved using our software in the back end somewhere. And we have a wide portfolio product, again, mostly in the file transfer, file management, file transfer. We have on-premise, in the cloud, SaaS offering. We have a huge set of products. As far as I've been working for Aspera for 4 years now. And I'm kind of a middleware geek, if you want. And my mission really has been, for the last few years, to take our core technology, FASP, and trying to see if we can make the same impact with streaming in general, data streaming, but especially video streaming, than we have for file transfers. So before we get into those things, today what I want to talk about, I want to talk to you about 2 things. I want to talk to you about our new protocol called FASPSTREAM. Give you a little bit more details on that. And then I want to tell you about what we call FASP.io, which is really kind of a software incarnation of this protocol and how to use it and how to leverage it in your various scenarios. But first, just to put things in context, and I'm sure I don't have to convince many of you guys what the problem is with video streaming over TCP. It's pretty simple. TCP sucks. That's the bottom line. We can go into detail. I can show you a graph here where, as you can see, in ideal condition, TCP does pretty well when there's no packet loss, no delay. But as soon as there's a little bit of packet loss, a little bit of delay, it just comes to a crawl. Okay? And this is what basically the core problem that our technology has been solving for years now. And so I'm introducing to you FASP and FASPSTREAM. Those are our transport protocol. And the big idea, basically, is that it provides a high-speed data pipe that's almost impervious to packet loss and delay. So you can see in blue here, no matter how much packet loss, how much delay, it's going to utilize a maximum of your bandwidth, basically. It can adapt to the available bandwidth to minimize packet loss. It's reliable. It's secure inherently. And FASP initially was very much built for file transfer. And then there's its little brother, FASPSTREAM, which really all it is, it's a certain flavor of our FASP protocol. So during the talk, I may say FASP or FASPSTREAM. I usually say FASP because it's shorter. It's the same protocol, but the difference is it's a byte stream-based protocol. And it provides in-order delivery, which is kind of important for streaming. And it's mostly for data streaming of any kind, but obviously it can be applied to video streaming. All of this is at the transport level. So we're completely agnostic to any video encoding, to any formatting, data type. We just move the bytes. So what are the advantages of FASPSTREAM? Well, basically, it can transfer predictably at the rate of the stream. Over a commodity internet, despite distance, which is usually the cause of loss and delay. It's nearly 0 startup time. Unlike FEC, forward error correction solutions, we really, there's no overhead to pay. The only overhead you have to pay is depending on the packet loss and some amount of retransmission. But there's no extra bandwidth utilized for forward error correction. There's low probability of buffering because of how we time things under the hood. When we talk about adaptive bit rates like technologies such as HLS or Dash and so on, because of how the algorithm really kind of scales up, it's gonna basically prompt the adaptive bit rate to use the highest speed available, the highest quality. This is available today. FASPSTREAM is available today. You can contact our sales and really get to play with it. The version that is available today is part of all our major products. You can enable it via license. It supports stream-to-stream, mostly point-to-point situations. It also supports very cool features such as stream-to-file or file-to-stream. I would recommend you come again at 4 o'clock and you see my colleague Jonathan Solomon's presentation. He's going to go much more in depth about what we currently can offer. And just as a long story short, where we've made a big difference with this already is for our broadcasters. So if you're a broadcaster, go check this session. This enables us to basically get rid of satellite trucks, which cost a bundle, and to really, the scenarios we mostly use it is to carry MPEG transport stream traditionally over UDP, but we can do it over FASPSTREAM. And really get awesome quality with zero loss and no glitch, but still as close to live as possible. So again, if you want more information on that, come at 4 o'clock. What I want to talk to you about today a little bit is our next generation platform. And it's basically, we all evolve in a kind of TCP world. For the better or for the worse, most web technologies today are TCP based. You know, HTTP, RTMP, they're TCP based. So how do we, without disrupting and having to change everything, how do we bring in this FASPSTREAM technology? So the FAST protocol, just to give you a little bit of context, it's a bit of a diamond in the rough situation that we have here because over the last 10 plus years, like I said, this protocol was mostly used for file transfer and for enterprise-centric scenarios. And so it came with a little bit of baggage that we now are trying to change. So what we want to do is preserve this diamond, preserve the gem that is the smarts, the 10 years of experience that we've put in this protocol on how we do the retransmission, how we compute the round trip time, and all this, the secret sauce, I would call it. But how do we package that in a way that's much more versatile, that really allows us to tackle use cases that we couldn't tackle before, and especially how does it allow us to go on every platform, especially mobile, I would say. So what is FASP.io? FASP.io is basically the name we gave to this new software platform for data transfer. From the get-go, we were really focused on streaming, keep it very generic. It's built around our new protocol called FASP v4. And what this brings in the picture is this protocol is now fully bidirectional. It's a client-server architecture. It's multi-session. It lives on a single UDP port. It uses DTLS for security. So it basically tries to alleviate some of the choices we made that were fine for enterprise, but that now have to be adjusted for a more kind of web and broader usage. The key is this runs on all platforms. We wanted to, from the get-go, we designed this to work on mobile, desktop servers, in the browser, on set-top box, Apple TVs and so on. We also, because we are in a TCP world, we wanted to make sure that we could very easily interface with the existing TCP and UDP protocols out there, and that's how people kind of interconnect things. So you can interconnect with the system using TCP, UDP, or WebSocket even. The goal was to be able to carry any TCP-based protocol. And I'm just naming a few here, but whatever TCP protocol you can think of, as long as it's quote-unquote data intensive, it's not a quick query response scenario where there's bulk data involved or a stream of data, we can basically carry this. One important principle as well is we wanted to have our API be as close to socket as possible so that everybody can use it, it's easy to integrate. And we want to provide native offers for most languages, C, C++, Swift for iOS, Java for Android, JavaScript for the browser. So let me go through a couple of use cases. And the sky's the limit. We can think of a lot of others, but I'm just going to focus on a couple. So video ingest using RTMP. So there's usually no CDN options for that. The last mile or first mile in this case, because we have a video source somewhere where we're trying to send to stream a video up to a server, the Wi-Fi could be bad, cellular network could be bad. And as we know, if the source is bad, everybody's playback is going to be horrible. So the source is really the key stream to improve. Our partners and first customers for this, IBM Cloud Video, you may know them as Ustream previously. That's why they're really excited about this, because they want to be able to use this to improve their customers' experience for any live events. Where, especially because in the case of IBM Cloud Video, they do not control what camera, what encoder, what connection to the ISP people have on the source. And we want to do this with requiring no change, because like I just said, they don't necessarily control the RTMP source, so merely a config change would be needed. Another scenario is the video playback over HLS or Dash. So today, you kind of have to use CDN if you want to address the scalability problem and especially the distance problem. And CDNs, as we know, are expensive. And no CDN will really help you in the last mile problem if the Wi-Fi is bad or the cellular is bad to the player. But here, too, we want to, as transparent as possible, integration with the existing ecosystem. And for example, we've tried our solution with JW Player, HLS JS, Dash JS, Bitmovin, all these players where we really integrate in a transparent way there. And in some cases, and that's really our hopes and dreams for the future of this, is depending on the size of your audience, if it's very kind of dispersed around the world and there's really only a few hundred or thousands of viewers, you could completely, thanks to our technology, bypass CDNs. So, I mean, I'm now shooting a little bit in the future, but that's our hope one day. But really, like I said earlier, we're completely agnostic to the data we carry. So you can conceive this being used in any TCP-based ecosystem. We have customers that do remote medical imaging, using a DICOM protocol. So they don't control their server or the client, but they can accelerate the streams using our technology. So because we live in a TCP world, we're providing you two very useful binaries. One of them is the FastBio gateway. So this gateway is mostly a server-side technology. It's CLI-based. And what it does simply is it translates any FASPSTREAM session into a TCP session or vice versa. So it's just a bridge between the two protocols. And you can stick that in front of a server and basically enable our technology without having to touch your server. It can also run in a point-to-point scenario. And then we have the FastBio Connect, which does very similar operation. It's basically a bridge between TCP, UDP, WebSocket to and from FASPSTREAM. But the difference is this is a lightweight desktop agent for Mac and Windows. And basically, it enables FastStream inside the browser for web apps or for any application that runs on your desktop. So very quickly, because I'm already running low on time here, the use case I'm talking about here, I've combined both use cases. So on the left, you have the ingest side where a camera source sends an RTMP stream over TCP to any RTMP server, really. And on the right, you have the playback scenario where we produce HLS or dash over HTTP. And how do we bring in using those two components that I gave you? Well, simply, all you need to do is put the FastBio gateway on your server, and on the client side, put the FastBio Connect, and now we can tunnel RTMP over the WAN using our protocol FASPSTREAM, gaining all the benefits of that over the WAN. But locally, on both sides, you just deal with a TCP connection as normal. And so all you really need to change here is instead of pointing your destination URL to the server, you point it locally to this FastBio Connect. And on the server, we just configure the gateway to redirect to the server, and we're done. And same on the playback side. But that's not enough, because here we don't have mobile and so on. So really, to gain mobile, we have SDKs. We have SDKs for most languages, and very quickly, and these are first-class citizens in this framework. We want to follow the well-known socket API. Why? Because it's easy to use. Everybody knows it already. And especially because if you already have an app or server or client that uses TCP, it's a line-for-line replacement. Where you say connect, you say fast connect. Where you say read, you say fast read. So it's as easy as that. It's fully asynchronous. We try to find the most appropriate paradigm for each language. So in C, it's the POSIX socket. In C++, I don't know if you guys are familiar, there's this beautiful asynchronous I/O library that's becoming the standard for network programming in C++, like literally the standard in C++ 20, called ASIO. So we really fully integrate with ASIO. It's just like an ASIO socket. You can do whatever you want with it. And Java, the famous Java socket, or the non-blocking I/O channels. On Swift, the Grand Central Dispatch, and in JavaScript, we match it to a WebSocket API, basically. And on top of that, we also provide helpers where we go the extra mile. If you are in an RTMP scenario, we can give you a modified version of librtmp to ease your pain. On iOS, we can give you a URL protocol hook. In the browser, we can hijack the XML HTTP request. So that's really a couple line change for you to do. So this is the full picture with the SDKs. You could see we can do an ingest from an iPhone and a playback on an Apple TV. And just to say that this is a generic architecture that can work for any scenario, really. So to finish up the timeline, we're trying to release FastBio Gateway and FastBio Connect by the end of the year, and the SDKs, C++ as well, JavaScript as well, and then the mobile stuff will come early next year, hopefully. Thank you very much. I don't know whether we have time for questions, but maybe you can take me aside after the presentation. We also have a booth in I can't remember, in this one, in this big room there. Thank you very much.